Hello, hello, hello. Welcome to another episode of Mr. Boskin Does Some Math. Today we are doing illustrative math, grade 8, unit 4, lesson number 10. Okay, our first problem here says match the lines M and N to the statements they represent. Let me move this up a little better so we can see. Get rid of that accidental blue line. A set of points where the coordinates of each point have a sum of 2. A set of points where the y-coordinate of each point is 10 less than its x-coordinate. So which one is which? Well, if each point has a sum of 2, let's look at this line. Here, the x-coordinate is 0, the y-coordinate is 2. 0 plus 2 is 2. Here, x is 2 and y is 0. 0 plus 2 is 2. Here's 1, 1. 1 plus 1 is 1. Line N has to be the first one, which means it's probably M for the other one, but let's check. If x is 0, y is negative 10. Set of points where the y-coordinate of each point is 10 less than its x-coordinate. Negative 10 is 10 less than 0. Here the x-coordinate is 10, the y-coordinate is 0. The y-coordinate is 10 less. So that one has to be M. Okay. Match the labeled points on the graph with the statements about their coordinate. Let me zoom out a little bit so we can see this better. Get my head out of the way a little better. Okay, match the labeled point on the graph with the statement. Two numbers with a sum of 2. What point is two coordinates with a sum of 2? Well, A is on that line. Negative 2, 4. Negative 2 plus 4 is 2. So A. B is also on that line, and C is also on that line. A, B, and C all work for that. Two numbers where the y-coordinate is 10 less than the x-coordinate. Ooh. That's what this line is the equation of, which means D, B, and E all work for that. Two numbers with a sum of 2 and where the y-coordinate is 10 less than the x-coordinate, which means both of those statements have to be true. Well, if I look at this, we have A, B, and C, and then D, B, and E. Which point is true for both of those? That's B right here. Okie dokie. Here is an equation. Four x minus 4 equals 4x plus what? What could you write in the blank so the equation would be true for no values of x? So for this to never be true, what would have to go in here? For it to be true for no values, in that blank, the left side and right side have to have the same number of x's but a different number of constants. So what could be in there? Anything that is not negative 4. So let's just say 7. There's nothing we can multiply by 4 and then subtract 4 that's the same as multiplying it by 4 and then adding 7. That's never going to work. All values of x. Well, that means each side has to be the same. So this would have to be negative 4. then each side of the equation is identical. Anything can work in the x. One value of x. For it to be true for only one value of x, we have to have a different number of x's on each side of the equation. Which means, what do we want to be adding here? X. Could be 2x's, could be 3x's. You have to have an x for it to be true for only one value. Okay, what problem is next? Okay, Mai earned $7 per hour mowing her neighbor's lawns. She also earned $14 for hauling away bags of recyclables for some neighbors. Priya babysits her neighbor's children. The table shows the amount of money M she earns in H hours. Priya and Mai have agreed to go to the movies the weekend after they have earned the same amount of money for the same number of work hours. How many hours do they each have to work before they go to the movies? So we want to know where both of these things are equal to each other. So if I look at Priya, it looks like makes $8.40 an hour. So that would be Y equals 8.4x. Mai earns $7 per hour. Per means we got the variable there. She also earned $14 for hauling away bags of recyclables. So she also got $14. Now, if we want to know how many hours they have to work, so we want to know when their x is the same and their y is the same. How can we do that? We can set the two equations equal to each other and do 8.4x equals 7x plus 4. Okay? How would we solve this equation? Well, step one is to get all the x's on the same side of the equation. So let's subtract 7x from each side, because the right side has x's and numbers and the left side only has x's. So we will want to get rid of x's over here and bring them all to the left side. Those cancel nicely. 8.4 subtract 7 is 1.4x equals, what's left? 4. Now, to get the x by itself, we have to divide each side by 1.4. Do it to one side, do it to the other. Those cancel. X equals, what is 4 divided by 1.4? Well, 1.4 is 14 tenths, which is 7/5. Dividing by a fraction means multiplying by the reciprocal. The reciprocal of that is 5/7. So we have to do 4 times 5/7, which is 20/7. So x equals 20/7, which is 2 6/7. I'm going to go ahead and say we might want a calculator for some of these. We now know that they work 27ths or 2 6/7 hours. How much will each of them have earned? So 27ths times 8.4 is $24. So that was Priya. Priya earns $24. And Mai is 27ths times 7 plus 4. Ooh, we just checked our work. Mai also earned $24. So the reason I wanted to check both of them, we found the point where it was true for both of them, but by plugging it into both of them, we proved that we solved this correctly. Explain where the solution can be seen in a table of values, graphs, and equations. For a table of values, it's where the x and y are equal to each other. In both tables, if we had a table of Mai, it would have to match. In a graph, it is where the two lines intersect each other. In a equation, it was where the two equations were equal to each other. For each equation, explain what you could do first to each side of the equation so there would be no fractions. You don't have to solve the equations. How many people are excited to see this saying you don't have to solve the equations? What would we have to do to get rid of these fractions? Well, I don't like this 8 and I don't like this 3. Well, 8 times 3 is 24. If I multiply this by 24, do it to one side, you have to do it to the other. Well, now I'm multiplying this whole thing by 24 and then dividing by 8. What's 24 divided by 8? Well, that's 3. So this side would be 3 times 3x minus 4, and the other side would be multiplied by 24 and then divided by 3. Well, 24 divided by 3 is 8. Ta-da! Then we'd have to distribute. I'm going to show on the first one here anyway what this would look like. 3 times 3x is 9x. 3 times negative 4 is negative 12. 8 times x is 8x. 8 times 2 is 16. Get all the x's on one side. Let's subtract 8x. Do it to one side, do it to the other. 9x subtract 8x is just 1x. Now this side has x, this side doesn't. So let's get rid of the numbers over here. So we'd have to add 12. Do it to one side, do it to the other. X equals 16 plus 12, which is 28. Hooray! Now, what about this next one over here? Well, we'd have to multiply by 8 to get rid of this fraction, multiply by 4 to get rid of that fraction. I'm pretty sure we can just multiply by 8. Multiply that by 8. Multiply that by 8. That 8 and that 8 cancel. We're left with 4p plus 3 equals On this side, we're multiplying by 8 and then dividing by 4, which is 8 divided by 4 is 2. 2 times p plus 2. Okay. A couple more of these. What would we have to multiply this by so there's no more fractions? Common denominator with 6 and 4 is 12. If we multiply this by 12, then divide by 4, we are multiplying by 3. Then we are again multiplying by 3 because of this 3 right here. 3 times 3 is, you guessed it, it's 9. Times 2 minus r equals 12 divided by 6 is 2 times 3 plus r. Okay, what do we need to do on this one? Here, we need to multiply by something that's going to take care of the dividing by 6 and dividing by 15. So, common denominator between 6 and 15 is 30. 6 times 5 is 30. 15 times 2 is 30. Ooh, times 2. Hey, we've got a times 2 here. Which means what's going to happen here if we multiply that by 30, multiply that by 30. 30 divided by 15 is 2, times 2 is 4, equals 6 divided by, 30 divided by 6 is 5. Times a plus 4. Beautiful. Okay, what have we got next? The owner of a new restaurant is ordering tables and chairs. He wants to have tables for 2 and tables for 4. The total number of people that can be seated in the restaurant is 120 people. Describe some possible combinations of 2-seat tables and 4-seat tables that will seat 120 customers. So, we could have 0 4-seat and 60 2-seat because 0 of those, 60 2-seaters, 60 times 2 is 120. We could have 30 4-seat and 0 2-seat because 30 times 4 is 120 people. What's another nice one? Well, what if we had 15 4-seats? Well, 15 times 4 is 60, so we'd have spots for 60 more people, which would be 30 2-seaters. Now, write an equation to represent this situation. Well, we would need first X and Y. What are they going to represent in this situation if we're going to write an equation? Well, let's have X be a 4-seat on top. So X will be the number of 4-seat tables. Y will be the number of 2-seat tables. So, please try to remember to write these out. I dislike it when students just say X is tables and Y is tables, or X is 4 and Y is 2. What do the variables represent? Perfect. How many tables of each are we going to need? Some possible combination of 2-seat and 4-seat, a total of 120. Well, each 4-seat table seats 4 people, 2-seat table seats 2 people, so this is going to be 4x plus 2y equals 120. 4 times the number of 4-seaters plus 2 times the number of 2-seaters is 120, which is the total number of people. Sorry, got my head in the way. You didn't want to see anything anyway. Create a graph to represent this situation. So, we had a couple nice points here on our graph that we can see from looking at what we've got over here. The most 2-seaters possible is 60, and the most 4-seaters possible is 30. And those will wind up being the X and Y intercept on our graph. So, create a graph. What do we want? We have X is 4, so 4 seat and then 2 seat tables. Now, how high do we have to go? We have to go to 60 in one direction, 62 seat tables, so let's count by 10. 10, 20, 30, 40, 50, 60, 70, 80. Now the other way, we have to get up to 30. So we don't have to go up so high, so let's count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. So we know a couple nice points on our graph. We know 0, 60, and we know 30, 0, and we know 15, 30. Those are the 3 original points we found. So we just have to connect the dots. What does the slope tell us about this situation? Well, we don't know the slope specifically. We haven't found it. Slope is the change in y over the change in x. Rise over run. If we were to have a triangle here, it has a rise of 60 and a run of 30. And it's going down. 60 divided by 30 is 2, so -2 is our slope. What does the slope tell us about this situation? Well, it tells us for every 1 that we go this way, we go down 2. So for every x, for every 1x, so for every 4-seat, we have 2 less 2-seaters. Which makes sense because a 4-seat table is 2 2-seat tables for the number of people it takes. So for every extra 4-seat table, we have 2 less 2-seat tables. Okay, that was our last one for today. This has been another episode of Mr. Boskin Does Some Math. Thanks for watching. We'll see you next time.